traveling far without a hope, but not without a star. Free, only want to be free. We huddle close, hang on to a dream. On the boats and on the planes, it's coming to America, never looking back again. We come into America. Oh, it seems so far away. Been traveling light today, in the eye of the storm, in the eye of the storm. Lord, we've been waiting so long, with only hope, but not without a star. Me, only want to be me. Been huddling close, hang on to a dream. On the boats and on the planes, it's coming to America, never looking back again. It's coming to America. Oh, it seems so far away. It's been a hard trip this way, through the eye of the storm, through the eye of the storm. Now the time is coming near, it's coming to America. Now the moment's almost here, it's coming to America. Got a dream to get us there, it's coming to America. Got a dream we've come to share, it's coming to America. It's coming to America. It's coming to America today. It's here today. It's here today. It's here today.
Space-age manufacturing technology, extensive testing, union commitment, quality control. These are the building blocks of Alliance quality. These are the elements of what the people at Kenosha are calling the quality partnership. We're going to show you how all of these components come together and contribute to making Alliance quality second to none in the world. The story starts here at the factory. We asked George Maddox, Vice President of Manufacturing, to show you how design and space-age technology contribute to quality.
At the turn of the century, the Lakefront plant was built as a mattress factory. American Motors converted it to an automotive plant 22 years ago and began to build Ramblers here. On the outside, it hasn't changed much. But inside, there's a new industrial revolution going on, using some of the most advanced automobile manufacturing techniques in the world today. You're going to be visiting a plant where the new Renault Alliance automobiles will be built to quality standards that are second to none in the world. Now, we're not going to take you through the entire manufacturing operation. That would take hours, and a lot of it would be repetitive. So today, you're only going to see certain highlights of our Alliance production lines. As background, the lakefront plant is the body assembly part of our operation. Here, sheet metal stampings, sealers, paint, soft and hard trim ornamentation, instruments, and other components arrive, all to be assembled into a complete trimmed body. These trim bodies are hauled to the final assembly plant nearby. There, the engine cradle, rear axles, wheels, tires, and accessories are added to the trim bodies to become finished Alliance automobiles, driven off the assembly line, tested, and shipped to dealers nationwide. Now, there's nothing terribly unique about the flow of these operations. What is unique is the new technology we're using to build the finest automobiles you've ever seen from us. A prime example of the new sophisticated engineering techniques we've introduced is a process called Unisurf. It was conceived and designed by Renault engineers in Europe. This is a space-age computer program that transfers the exact surface of a clay model directly to the tool that will stamp the surface. The tools and assembly fixtures are designed to be checking fixtures as well. This Unisurf process is a zero-defect system that allows in-process checks of every assembly on the Alliance body. What that means is that the 100,000th Alliance is exactly the same as the first one. This is the most advanced design, manufacturing, and checking system used anywhere in the world today. Unisurf is the heart of the body assembly operations here at Lakefront. To assemble precision-made stampings, we've introduced an automatic framing process. Here on what we call the Gilman line, the major body subassemblies of the new Renault Alliance are welded together. The Gilman machine positions the body sides, cowl, underbody, front end, headers, and roof, and clamps them precisely together, and then welds them with remarkable accuracy. The welding operations are performed by a new generation of manufacturing robots. The door, hood, and deck lid openings on this line vary no more than plus or minus 3/4 of a millimeter from one body to the next. These new body tolerances translate into customer satisfaction. Wind noise and water leaks are reduced and consistent fit is maintained. Here's another machine that builds doors and customer satisfaction. This French Siaki machine builds dimensionally consistent doors for either 2-door or 4-door models. This new process saves time, labor, and space. These doors fit into an Alliance 4-door body, which is composed of only 2 major stampings. The combination results in the best door fits you've ever seen on an American car, and as good as the best of the Japanese. All Alliances have a 5-year warranty against corrosion perforation. This outstanding protection is due to finishing operations that are as advanced as any in the world. No mass-produced car built anywhere gives a more thorough, complete corrosion protection treatment than the Renault Alliance. All exterior body panels are galvanized for maximum protection. Following a zinc phosphate metal treatment, bodies are immersed into a cathodic electrocoat process. Each body is given an electric charge while the prime dip carries an opposite charge. The result is an even completely coated car inside and out that will last longer and look better. All Alliance metallic colors will have a final coat of clear enamel for that deep quality look found heretofore only on the most expensive domestic automobiles. Our new metal coating technique will produce superbly finished automobiles that will rival the best of the imports, including the Japanese. The instrument panel on the Alliance is built as a separate subassembly. All electrical components and wiring can be checked for electrical continuity and function prior to installation in the vehicle. After the assembly installation, every component in every vehicle is checked. Our goal is 0 defects in manufacturing, and to achieve that, we have to have advanced engineering, the latest techniques, and a continuing system of checks and electronic inspection. Renault, of course, is the premier builder of front-wheel drive vehicles in the world. The front-wheel drive Alliance was designed with an engine cradle which is being built on this line. This engine cradle is unique for a vehicle in Alliance's class. The cradle, which is assembled to the engine, transaxle, radiator, front suspension, steering and brakes, is attached to the body with 4 bolts. This allows for a simpler assembly, a feature which leads to higher quality. The engine cradle, which is actually a separate structural member from the body, dampens engine vibrations normally transmitted directly to the passenger compartment. I'd like you to keep in mind that we've made a commitment to management of American Motors, and to our dealers, to our owners, that your new Alliance will be built to quality standards that are second to none in the U.S., or in Europe, or in Japan. Quite simply, our goal is to produce the finest, best-built automobiles in the world.
This is American Motors Proving Grounds at Burlington, Wisconsin. 360 acres and 14 miles of roads dedicated to one thing: to know the durability, reliability, and safety performance of our vehicles before a customer gets behind the wheel. Burlington is, in reality, nothing less than an engineering tool. The tests here are rigorously controlled. The drivers work to an exact schedule. Every cycle over the bumps, every full throttle run at a steep grade is all part of a carefully developed plan. The road surfaces never change, the course never changes, and the test specifications never change. The only variable here is the car. Here's a bird's eye view of the 4 main test areas on site. The upper track is the primary durability circuit. Here, a car can be literally driven to destruction in just 5,000 miles. The main track is directly to the west and features a 1.2-mile oval for 55-mile-per-hour driving. Inside the main track are 2 loops, which comprise the other durability course. This loop tests the durability and integrity of the chassis. This one is for the drivetrain. To the north track with over 20 different test areas is designed to help engineers analyze ride and handling characteristics. The nerve center of the proving grounds is in this building. Here, the critical inspection and precise measurements are taken after each phase of the test. The data is then sent on to American Motors engineers in Detroit. Essentially, the tests carried out here fall into 3 different categories: durability, reliability, and safety. The durability tests are designed to determine the life of all the components and chassis structures in the car. To measure durability, we literally drive the car to destruction. During this drive to destruction, we're looking for answers to 2 fundamental questions. First, what is the sequence of failure? In other words, what component or part gives out first? What second, third, and so forth? Second, and of equal importance, we want to know the mode of failure. How does a part fail? Does it break down slowly over a period of time? Does it go all at once? And how does its failure impact other parts? There are several types of durability tests. One of the key programs is the 20,000-mile General Endurance Test, which covers the entire vehicle. These tests take from 18 to 20 weeks of driving to complete. During that time, the car is repeatedly exposed to a variety of extreme road surfaces, which are designed to accelerate the normal wear on the car. For example, on the inner track durability loop, the vehicle is put through an alternate roll surface, which places greater than normal stress on the shocks, the chassis, and linkage. We have surfaces called shimmy exciters. If the car has a tendency to shimmy, this particular bit of surface will reveal it. In addition, there are dips and washboards, which send high-frequency vibrations through the car, plus things like railroad crossings, chatter strips, and an assortment of bumps. On the adjacent loop, the road is designed to place maximum stress on the drivetrain. The test drivers come to a stop at the base of a grade and then give it full throttle without braking traction. Again and again, the drivetrain is subjected to punishment far beyond that expected once the car is in the hands of the consumer. While this may not represent typical driving, we must know how our cars will perform under the most severe demands. The third durability test is by far the most brutal. On the upper track, a car is exposed to 5,000 miles of the worst road conditions imaginable. There are deep shock-crunching potholes, a ripple track which creates a torturous vibration through the car, a body twist which sets up a high-amplitude situation that pulls at every seam, every weld in the chassis. And there are cobblestones, bruising rocks that pound the steering system, the shocks, and the linkage. At predetermined mileage intervals, the cars are brought into the main garage for inspection and a host of measurements. Here, trained mechanics search the underbody for signs of cracks and metal fatigue. In addition, they also check the paint for resistance to chipping, and they note the characteristics of stone spray from the tires. Once the inspection is complete, it's back on the road again. By the time this car is ready for the scrap heap, we'll know what breaks, when, and how. And that information will provide AMC engineers with the data they need to help ensure that every AMC, Jeep, and Renault vehicle meet our stringent durability standards. The second major test is reliability. Very simply, the reliability tests are designed to help us predict and anticipate what the customer will encounter during the life of the car. In these tests, the cars are driven an accelerated 50,000-mile course, which is the equal of 100,000 miles of typical driving. 16,000 of those miles are driven on the main and inner tracks, while the remaining 34,000 is accumulated on public highways in southern Wisconsin. As with the durability tests, the cars are brought in for inspection. Data is collected, observations made, and reports sent back to AMTEC. There must be no surprises. We must know all there is to know about the life cycle of each of our cars. The third major test area is safety, and here the tests can be broken down into two major categories. There are the bumper standard tests, where the cars run into a barrier at 5 miles per hour to ensure that bumpers meet federal regulations. And there are 30 mile per hour crash tests. At the crash site, we determine things like steering